Hi, my name is Zijun Guo. I'm an assistant professor of computer science at UMass Amherst. My research interests include the use of wearable computing to understand human health.
My name is Jeremy Gummison, and I'm an assistant professor in the Department of Electrical and Computer Engineering. My research interests are around designing low-power hardware-software systems that enable closed-loop sensing applications.
My name is Nur Mohammed. I'm a PhD student in the Electrical and Computer Engineering department. My research focuses on developing an RF system, exploiting human body for wireless power transfer.
Current wearable devices are powered by on-device battery, and that causes a lot of constraints on the usability. First, having to charge on-device battery has been identified as the main reason that users discontinue the long-term use of wearable devices. Second, having to take off the wearable sensor to charge cannot support truly continuous monitoring of health condition. For example, the users have been using their bedtime to charge up their wearables, and therefore they could not use the wearable devices to monitor their sleep patterns, which contains a lot of important information about their health condition.
We introduced our system called Shazam, which allows a wearable device to be seamlessly recharged while the user is wearing it.
Here we are showing an application that the user is naturally interacting with the keyboard, and the keyboard area is equipped with a power source that can transfer the energy carrier to these electrodes, and the energy will be transferred through the human skin and be captured by this wearable device. As you can see, there's no whatsoever battery inside this electronics. And as soon as you make a contact with an electrode, you will see that the LED is actually blinking on it, which implies that the power is actually being transferred through the human skin.
The key concept that we exploit in our system Shazam is using human tissue as a transfer medium for power. The way that this works, right, is in this device, we have an electrode that couples to the human body, which you could think of as the red wire if you're thinking of a traditional battery with a pair of red and black wires. So the red wire is used to conduct current through the human skin, right? But where is the black wire that you would normally find in a battery? The black wire is actually established using an electrode on the device and another electrode that's embedded in the environment, and in this case, a daily object. And the coupling between these two electrodes establishes this return path. Currently, Shazam only transmits small amounts of power through the human body. And this is by design because of safety regulations that have been established by the FCC. You can think of the amount of power that's transmitted by Shazam as roughly comparable to what's transmitted through the human body when you stand on a body composition scale. To compare this amount of power to a conventional smartwatch that's available today, it's much smaller, but we imagine that in the future, as we further optimize the power that's consumed by the wearable sensors, we could reduce the charging time needed to fully recharge the battery of the sensor to be on the order of minutes.